Long-term capital management. Managed by Nobel Prize winners. $125 billion in assets. On a single day in 1998, they lost $550 million. Their 99% model said this should happen less than 3 times per decade. It happened because of one assumption. A distribution assumption. By the end of this lesson, you will know exactly which assumption they got wrong, and why the CFA exam tests it on almost every quant section. 6 to 9%. That is the official CFA Level I exam weight for quantitative methods. Roughly 11 to 16 questions out of 240. And probability distributions is the single highest tested subtopic inside quant. Schwesser data shows 68% of wrong answers on this topic come from just one error: the T versus Z decision. Master that one rule, and you capture most of the marks. Start with the binomial. You have n independent trials. Each trial has exactly 2 outcomes: success or failure. Probability of success is P. The formula for exactly k successes has 3 parts. First, C of nk, the number of ways to arrange k successes across n trials. Second, p raised to k, probability of k successes in sequence. Third, 1 minus b raised to n minus k, probability of the failures. The trap the exam sets. Candidates multiply p to the k by 1 minus b to the n minus k. And forget the binomial coefficient entirely. That gives you the probability of one specific arrangement. You need all of them. The normal distribution. Symmetric. Bell-shaped. Defined entirely by 2 parameters, mu and sigma. Here is the rule every CFA candidate must tattoo into memory. 68% of observations fall within 1 standard deviation of the mean. 95% within 2. 99.7% within 3. But here is where the exam traps you. These percentages only apply when the endpoints you are given are exactly 1, 2, or 3 standard deviations from the mean. If the endpoints are not round multiples of sigma, you must calculate the z-score first. Always. Standardization. This is how you convert any normally distributed observation into a z-score you can look up in a table. Z equals x minus mu divided by sigma. X is your observation. Mu is the population mean. Sigma is the population's standard deviation. A z-score of positive 1.96 means your observation is 1.96 standard deviations above the mean. And that specific number, 1.96, is the critical value for a 95% confidence interval. Remember it. The exam will ask for it directly. 3 critical z-values. Memorize these. For a 90% confidence interval, z equals 1.645. For 95%, z equals 1.96. For 99%, z equals 2.576. Here is the CFA exam pattern. They give you a confidence level and expect you to recall the critical value instantly. No derivation. No table. 1.645, 1.96, 2.576. Say them out loud now. You will thank yourself on exam day. Why can't stock prices follow a normal distribution? Simple. A normal distribution extends to negative infinity. That would mean a stock could trade at negative $50. Impossible. Limited liability means a stock price cannot go below 0. Enter the log-normal distribution. If the natural log of x is normally distributed, then x itself is log-normally distributed. Equivalently, if y is normal, then x equals e raised to y is log-normal. Stock prices are log-normal. Daily log returns are approximately normal. Black-Scholes, the model behind a $500 billion daily options market, is built entirely on this assumption. Normal versus log-normal, side by side. Normal distribution. Symmetric, ranges from negative infinity to positive infinity, used for returns. Log-normal distribution. Right-skewed, bounded below by 0, used for asset prices. Here is the exam trap. Answer choice C will tell you stock prices are normally distributed because daily returns are approximately normal. That is false. Normally distributed returns imply log-normally distributed prices, not normally distributed prices. The exam exploits this distinction every time. Now the most tested decision in all of CFA Quant. When do you use T? When do you use C? Here is the two-question decision rule. Question 1, is the population variance known? If yes, use C. Question 2, is the population variance unknown? If yes, use T. Sample size matters too. Small sample unknown variance, always T. Large sample unknown variance, still technically T. But the difference from Z becomes negligible. The exam tells you which to use through one keyword. If the problem says population standard deviation, that is Z territory. If it says sample standard deviation, that is T territory. Every time. Confidence intervals. The formula has 3 parts. The sample mean, plus or minus, the critical value, times the standard error. The critical value is either T or Z. You just learned that decision rule. The standard error is the sample standard deviation, divided by the square root of n. Here is the most common arithmetic error on the CFA exam. Candidates forget to divide by root n. They use the raw standard deviation instead of the standard error. That produces an interval approximately 7 times too wide. Divide by root n. Always. Exam question. A stock return is normally distributed with mean 12% and standard deviation 20%. What is the probability the return falls between -8% and 32%? Pause and work through it. The key step, standardize both endpoints first. Z1 equals -8 minus 12, divided by 20, that gives -1. Z2 equals 32 minus 12, divided by 20, that gives +1. You are within plus or minus 1 standard deviation. That is 68%. If you answered 95%, you defaulted to the wrong rule. The 68, 95, 99.7 rule only applies when the endpoints are exactly 1, 2, or 3 standard deviations. Always calculate z-scores first. Exam question. An analyst constructs a 95% confidence interval for the mean return of a portfolio. Sample 30 observations, sample mean 8%, sample standard deviation 15%. Population variance is unknown. Which critical value is correct? The answer is T with 29 degrees of freedom, not Z equals 1.96. 2 conditions trigger T. Population variance is unknown, check. and sample size is only 30, borderline small. Using z equals 1.96 here would underestimate uncertainty and produce a confidence interval that is too narrow. Degrees of freedom equals n-1, not n. 1 degree of freedom is lost because the sample mean is used to estimate the population mean. 29, not 30. The hardest question on this topic. A confidence interval is calculated as 4.2% to 11.8%. Which interpretation is correct? The answer is B. If you answered there is a 95% probability, the population mean lies between 4.2 and 11.8. You chose the most common wrong answer in all of statistics. Here is why it is wrong. The population mean is a fixed constant, not a random variable. Once the interval is calculated, the mean is either in it or not. There is no probability left. The 95% refers to the procedure. If you repeated this sampling 100 times, approximately 95 of those intervals would contain the true mean. The arrow analogy: before you shoot, there is a 95% chance you hit. After you look at where the arrow landed, it either hit or missed. No more probability. Lognormal application question. Which of the following is least likely to follow a lognormal distribution? A. Stock price at a future date. B. Real estate property value. C. Daily change in stock price in dollars. D. Future value of an investment with reinvested returns. The answer is C. Daily price change. Price changes can be negative. A stock can fall in value. Lognormal distributions are bounded below by 0. They cannot take negative values. Stock price levels are lognormal because they cannot go below 0. Price changes, which can be negative, could follow a normal distribution. The exam uses the word change to test exactly this distinction. Level versus change. Lognormal versus normal. Screenshot this. Everything you need for the probability distributions exam questions. On one frame. Binomial, E equals NP, variance equals NP times 1 minus B. Normal, 6895, 99.7 rule. Always calculate z-scores before applying percentages. Critical z-values, 1.645, 1.96, 2.576. Lognormal, bounded above 0, right-skewed, used for asset prices. ln of x is normal if x is lognormal. Students T, use when population variance is unknown. Degrees of freedom equals n-1. Confidence interval, x bar plus or minus t star times s over root n. Never omit the root n in the standard error. And the confidence interval interpretation. 95% refers to the procedure, not the specific interval. This one frame could be worth 3 or 4 marks on exam day. Three exam day strategies that save you time and marks. Strategy 1, the distribution decision tree. Read the question stem and circle 2 things. Does it say population standard deviation or sample standard deviation? And what is the sample size? Population standard deviation, go to Z. Sample standard deviation, go to T. Takes 5 seconds. Strategy 2, always calculate z-scores before applying the 68, 95, 99 rule. Even when the answer seems obvious, the exam will give you a range that is not a round multiple of sigma. And one of the wrong answers will be a round percentage designed to trap you. Strategy 3, On confidence interval interpretation questions. Eliminate any answer that puts a probability on a fixed parameter. The population mean is fixed. It cannot have a probability. Eliminate A, keep B. 3 strategies. 3 marks saved. That is how you pass.